calculus, in this lesson we're going to study two topics. One of them is arc length of a smooth curve, and the other one is surface area of revolution. So we start off with arc length, and what you're going to be doing is you're going to just be finding the length of a piece of a curve. So on my graph over here on the right, between A and B, if I use this formula right here, I would be finding the length of this blue piece right there. You can also do this with respect to y. These formulas will need to be memorized, so make sure you spend a little time memorizing them. You might want to put them on a note card. But once you do a few of these problems, I think you're going to get the formula memorized right away. We're just going to start off with the distance between 2 points on a line. So we're going to apply the formula. We're using f of x, so we'll be using this first formula. S equals from a to b, the square root of 1 plus f prime of x, quantity squared dx. Now, with your example, the 2 points are x of 1, y of 1, x of 2, y of 2. So x of 1 and x of 2 are actually going to be your a and b. So we're going to go from x of 1 to x of 2. We're going to take the square root of 1 plus. Now the slope of our line is just going to, or the first derivative of f of x is just going to be m. B is a constant and m is the coefficient in front of x. Well, you know that slope is actually y of 2 minus y of 1 over x of 2 minus x of 1. So I'm going to put that into my formula. We're going to square that. Okay, the next thing we're going to do is we're going to get a common denominator and kind of clean this up a little bit. So we have x of 1, x of 2, square root of, let's see, 1 plus, it's going to be a big one, 1 plus y of 2 minus y of 1 quantity squared over x of 2 minus x of 1 quantity squared dx. Then we're going to get a common denominator. And then we will go ahead and, let's see, we're going to take the square root of the top and the bottom. So I'm just cleaning it up a lot before I integrate. I won't have that squared anymore. All right, now I'm ready to integrate this. Well, don't be afraid to integrate this. X of 1 and x of 2 are just numbers. They're x coordinates. So this whole thing right here is nothing but a big constant. So when I integrate that, I'm just going to get that. Oops, I started writing x squared. Let me fix that notation real quick. Use that eraser here. So I have this. This is my constant. And then if I integrate a constant, I get x back. So just think about if you had to integrate the number 4. you would get 4x plus c. Well, I have integrated, instead of the number 4, I integrated this big thing right here, which is nothing but a number. So I would get back the number times x. And I will evaluate that from x of 1 to x of 2. When I do that, I have my numerator plus my denominator, or plus y of 2 minus y of 1 squared over x of 2 minus x of 1 times, and then I'll be plugging in these bounds and subtracting them. So it's going to be x of 2 minus x of 1. Well, that cancels. So my arc length, S, is nothing more than the distance formula between the 2 points. That's pretty cool. So in geometry, you would have found the distance formula between 2 points by applying the Pythagorean theorem. In calculus, you find the distance between 2 points by using this formula right here. Now you'll have one of these in your practice problems. In fact, it's the first problem. So I'm going to ask you to actually find the distance between 2 points using this formula that I've circled here in purple, and also using your distance formula. And you should get the same answer twice, of course. So you get to play with that one on your very first practice problem. Now we're going to get into some more calculus-like examples. So we have this first one here that is a curve instead of a straight line. We have x to the third over 6 plus 1 over 2x, and we're going to find the arc length between 1/2 and 2. So we're going to be setting it up as the integration between 1/2 and 2. And then we will have, of course, 1 plus y prime squared, and then we will be doing dx here on the outside. I don't know what that is. Let me fix that. All right, I think it's easier to find all of this first before we actually start integrating. So I kind of go through a series of steps. I'm going to start off with just finding y prime. So I'm going to rewrite my f of x first. All right, and then my y prime is going to be 3x squared over 6 plus 1/2 times -1 x to the -2nd. And I'm just going to clean that up a little bit. 1/2 x squared minus 1 over 2x squared. Another thing I can do here is I can take and factor out of 1/2. Okay, fair enough. From here, that's just y prime. I've only found this much here. I need to square it. So my second step is going to be squaring y prime. So I'll be squaring 1/2 x squared minus 1 over x squared. And for that, I'll be foiling. So 1/4 x to the 4th. Now, some interesting things happen. When I multiply and do my inner and outer terms, I'll have x squared over x squared. Well, that happens twice. So that's actually going to be a -2. Oops. Plus 1 over x squared. Okay. All right. now what we need to do here is take and add 1 to that. So we're still not ready to put it under the radical, but we're getting there. So the next thing we do is we're going to take y squared, we're going to add 1 to it. Oh, I just found a mistake. When I squared that, it should be to the 4th power, so sorry about that. Okay, I'm going to clean that up a little bit. Did it again. Okay, so 1/4 x to the 4th. 1 minus a half is a half. All right. So now I've added 1 to it. I'm going to clean that up, and then I'm going to be sticking that under the radical. Okay, I'm going to factor out a 1/4. That's going to give me a 2 here, I believe, because 2 times the 4th is a 1/2, and 1 over x to the 4th. Okay, that can actually be factored. I know it can be factored because look, this is similar to this right here. And so I can factor it back to 1/4, and then x squared plus 1 over x squared. So if you look back, this factored here, if I go backwards, so same idea, and this would be squared on the outside. Okay, that gets put under the radical. So we are just about ready to integrate. We're going to take that quantity and put it in right here. So we're going to be going from 1/2 to 2 of the square root of this guy right here, 1/4 x squared plus 1 over x squared squared. Okay, 1/4 x squared plus 1 over x squared squared dx. Well, taking the square root of that's going to be quite nice. I'll have 1/2 x squared plus 1 over x squared dx. And then I'll integrate that. See, I can take the 1/2 on the outside. Integrate x squared would be x squared, x to the 3rd over 3. Let's see, that's x to the -2nd, so I'd add 1 to that, -1 over x, and I'm going to go from 1/2 to 2. And then we're just going to clean that up. See, I'm going to go ahead and get a common denominator of 24. Let's see, 64 minus 13 is 51 plus 48. Looks like 99 over 24. I can divide both of those by 3. So 33 over 16. So what you're going to find is that these problems do require a lot of work. There is going to be one that I'm going to allow you to use your calculator on to integrate. But other than that, once you get all of this legwork done first, so once you get all of this taken care of first, the integration itself shouldn't be too bad. We're going to